Hi everyone, in this lesson we're going to look at calculating a percentage change without a calculator. In our first example, we're going to use bar models to help us visualize the percentage change. It says calculate the percentage change from 15 to 20. And when we're talking about percentage change here, we're talking about what percentage of the original, in this case 15, was gained in order to give us 20. And the bar model helps us to see that. So here's 15, our original. We can see that we've gained 5 to take us to 20. And what we want to know is what percentage is this amount, the amount we've gained, relative to the original, which is 15. And we've got a formula for percentage change that we can remember. It's as follows. The percentage change is equal to the change over the original, multiplied by 100. And in this question, the change is 5. We've gained 5. The original was 15. And then we need to multiply that by 100. This fraction just shows us what is the change relative to the original. What percentage of the original has been gained, in this case it's a gain of course, to get us to the 20. This is a non-calculator question, so I'm going to go ahead and simplify my fraction by dividing by 5 on the numerator and 5 on the denominator, and it gives me 1/3 multiplied by 100. 1/3 is one of those decimals that we need to know. It's 0.3 recurring multiplied by 100. And if I do that, it gives me an answer of 33.3 recurring percent. And when it comes to percentage change questions, we always want to say whether it was an increase or a decrease. In this case, because we went from 15 to 20, we can see that it was a percentage increase. So my answer is going to be a 33.3 recurring percent increase. So this sentence would be my final answer. The percentage change was a 33.3 recurring percent increase. Give this question a go. Calculate the percentage change from 30 to 45. Again, we can see that this is clearly a percentage increase, so we want to bear that in mind for later. Let's go ahead and start with our formula. The percentage change is equal to the change over the original multiplied by 100. This multiplying by 100 just turns it into percentage. That's how we go from any fraction to a percentage. The change in this case is the 15 that I've gained. The original was 30, so I started with 30, ended up at 45, so that's my original. Multiplied by 100. 15 over 30 is 1/2. And then what I do is I turn that half into a decimal, so 0.5, multiply that by 100, and that gives me 50%. Then I use my common sense. Well, it went from 30 to 45. I've already said that's an increase, so it's a 50% increase. In other words, 50% of 30 is 15, and when we add that on to 30, we get 45. My final answer is a 50% increase, and that's my answer. Our next example says calculate the percentage change from 40 to 32. First thing we want to point out is that this is going to be a percentage decrease in this question. As you can see, I've started with my 40. I've lost some amount to take me down to 32, and the bar model shows me that I've lost 8. I want to know what fraction of 40 is the 8, and then turn that fraction into a percentage. We'll start with our percentage change formula. So change over original multiplied by 100. The change in this case is 8, that's what I've lost. And my original was 40 multiplied by 100. Go ahead and simplify that fraction, so both of those are divisible by 8. If I divide the numerator by 8, I get 1. If I divide the denominator by 8, I get 5. If I have this 1/5 as a decimal is 0.2. And then I'll go ahead and multiply 0.2 by 100 to get me to 20%. And then I'll use my common sense. Well, it went from 40 to 32. It's a decrease. My answer is a 20% decrease. So always make sure you write that bit in words. Give this question a go. Calculate the percentage change from 80 to 60. Again, this is going to be a percentage decrease question. So your formula is as follows. So the percentage change is equal to the change. In this case, that is 20. I've lost 20 from 80 to take me to 60, and I want to know what percentage is the 20 of the 80. My original is 80, and then I need to multiply that by 100 to turn it into a percentage. 20 over 80, I can divide both of those by 20. 20 divided by 20 is 1, and 80 divided by 20 is 4, so I get 1/4. 1/4 is 0.25 as a decimal, And then we multiply that by 100 to take us to 25%. So my answer is a 25% decrease. The key thing to remember here is that it's always relative to the original. So we're going to look at the percentage change formula, and I'm going to express it in a slightly different way compared to last time. So we'll say the percentage change is equal to the final subtract the original. So that's the final value, take away the original value, over the original value. Remember, it's always relative to the original, multiplied by 100. So sometimes you might see that formula, and this top line here, the final subtract the original, well, that's of course going to be the change, which is the same as what we've seen in our first few examples where we had the change over the original multiplied by 100. So it's just a slightly different way of writing the formula. Instead of writing change, we can write final subtract original. In this question, we went from 70 to 98, so always good to get our common sense in early. It's going to be a percentage increase. My final value is 98. My original value is 70. And of course, on the denominator, I'm also going to have that original value of 70 multiplied by 100. 98 subtract 70 is 28 over 70 multiplied by 100. I can see that these are both divisible by 7, so I'll divide by 7 on the numerator and also on the denominator. And I could simplify that fraction further, but there's really no need. I can turn it into a decimal, 0.4. Nice and easy using place value. And 0.4 multiplied by 100 is 40%. And remember, we always need to say if that's an increase or decrease. Well, it's a 40% increase in this case. And that's your answer. We need to be aware that when we have this formula, if our final answer is less than our original, we're going to have a negative number on top. And what I mean by that is, let's say we were looking at the percentage change from 100 to 40. Well, we know that that's clearly a decrease. And if we write out our formula, percentage change is equal to the final subtract the original over the original multiplied by 100. Our final value in this case is going to be the 40, and we're going to be taking away something that is larger than 40, the original, which is 100, and we get a calculation like this. Now, when you do this calculation, 40 subtract 100, you get an answer of negative 60. And remember, I'm dividing that by 100 and then multiplying it by 100, so these actually cancel each other out. My answer is negative 60%. And because it's a negative number, we know that that's a percentage decrease. To save ourselves the problem of having to interpret this, I would probably use the formula percentage change is equal to the change over the original, and just always keep the change as positive, and then just use your common sense to interpret whether it's an increase or a decrease. But I did want to show us this formula because sometimes it is used. Pause the video and give this question a go. Calculate the percentage change from 150 to 30. This is clearly a percentage decrease. Let's bear that in mind. And we have two options to do this question. The first is to use the formula that I used over here. So that's the percentage change is equal to the final subtract the original divided by the original multiplied by 100. Or we can use the formula the percentage change is equal to the change divided by the original multiplied by 100. And all we have to be happy is that this numerator, the final subtract the original, is the same thing as working out the change. Let's use this formula to start with. So the final value was 30, the original was the 150, and that's what's also going to be on my denominator like this. If I do 30 subtract 150, that gives me negative 120 over 150 multiplied by 100. Then I go ahead and simplify that fraction, so I could divide through by 10 to start, then divide both of those by 3. So negative 12 divided by 3 is negative 4, and 15 divided by 3 is 5. I get negative 4/5 multiplied by 100. Negative 4/5 is negative 0.8 as a decimal multiplied by 100, and this is equal to negative 80%. And then we just need to be clear that that is clearly a 80% decrease. I wanted to show you this formula because it is sometimes used, but this is probably what I'd be using most of the time. I would just work out the change. The change from 150 to 30 is 120, and I'd just keep that positive, but I'm going to interpret it as a decrease at the end. The original was the 150 multiplied by 100, Go ahead, like I did before, simplify this fraction. 12/15 goes to 4/5. 4/5 is 0.8. Multiply by 100, and that comes out at 80%. And I just write that final line because it went from 150 to 30. I know it's a decrease. It's an 80% decrease. So you can use either formula. I prefer the one on the right. Just keep it simple, keep the numerator a positive number, and then just use your common sense to figure out if it was a decrease or an increase. We're now going to look at percentage change in context. Family installs solar panels and their daily electricity consumption drops from 50 kilowatt hours, kWh, to 41 kilowatt hours. Calculate the percentage change in their electricity usage. So just to draw your attention to this unit, kilowatt hours, that is a unit that measures electricity consumption. We abbreviate it to kWh like this. Let's start by writing out our percentage change formula. So percentage change is equal to the change over the original multiplied by 100. The change, well, it went from 50 to 41. So that is a change of 9. It's a decrease, of course, so we know it's going to be a percentage decrease. The original was 50. And then we need to multiply that by 100. This is a non-calculator lesson, so we need a way of doing 9/50 multiplied by 100. And there are two different ways. I could turn the 9/50 into a decimal and then multiply it by 100, or I could think of this as a fraction over 1, and then I could do some cross-simplifying. I could divide through by 50 on the numerator up here, and divide through by 50 on the denominator down here. Then I can do 9 multiplied by 2 to give me 18, and I would be doing 1 multiplied by 1 to give me 1. So it gives me 18 over 1, which is equal to 18%. So that's one way to do it without a calculator. The other way is to turn 9/50 into a decimal. So to turn 9/50 into a decimal, I would write it as a fraction with the denominator of 100. So I'd multiply 50 by 2 to take me to 100, and I'd multiply my 9 by 2 to take me to 18. Then I'd be multiplying that by 100. At this point, I can spot that if I've divided something by 100 and then multiplied it by 100, those cancel each other out and it just leaves me with 18. Or I could turn the fraction 18 over 100 into 0.18, then multiply that by 100. But either way, I end up with this answer of 18%. Remember, we always need to say if it's an increase or decrease. Their consumption drops, so it's a decrease. My answer is an 18% decrease, like this. You can pause the video and try this one. Micah can do 25 push-ups in a row. After 3 weeks of practice, he can do 31. Calculate the percentage change in the number of push-ups he can do. So the percentage change is equal to the change over the original multiplied by 100. He has increased, so it's a percentage increase. He's went from 25 to 31, so that's a change of 6. He's increased his number of push-ups by 6. The original was 25. Then multiply that by 100. 6/25, turn that into a fraction with the denominator of 100. So do 25 multiplied by 4. So I need to do 6 multiplied by 4 to take me to 24. Multiply that by 100. These 100s cancel each other out because I've divided by 100 and then multiplied by 100. My answer is 24%. And we said that it's a 24% increase. So that's what you should have got. So the last type of examples we're going to look at are percentage profit and loss questions. And these are a specific type of percentage change question that come up quite frequently. Let's jump into our example. Scott buys a faulty smartphone for £45. To repair it, he buys a replacement screen for £13, a new battery for £9, and a camera lens for £3. Scott then sells the phone for £91. Calculate his percentage profit. So in the same way that we had a formula for percentage change, we also have a formula for percentage profit, and it's this. Percentage profit is equal to the profit divided by the cost multiplied by 100. In other words, we're considering what fraction of the cost was profit. Profit just refers to the difference between the income and the costs. So how much money did he get from selling it? Take away how much it cost him to sell it. Now, another term that you might hear is what's called profit margin. And this is different to percentage profit because the denominator is different. So profit margin is actually profit over the sale price, multiplied by 100 if we wanted it as a percentage. Now, the difference between these two terms, percentage profit and percentage margin, comes from the difference from their denominators. In percentage profit, we're considering our profit relative to the cost, Whereas in profit margin, we're considering our profit relative to the sale price. Percentage loss is also relative to the cost, but the difference is that the numerator is going to be loss, not profit. It's also worth defining what profit is. So profit is income subtract costs. The income in this example is how much money Scott got from selling the phone. So it says Scott sells the phone for £91. He doesn't get any other income in that sense. The costs, there are a few different costs in this question. He buys the smartphone for £45, so that's a cost. And then all of the replacements are also costs. So to repair it, he buys the replacement screen, that's £13 of costs, the new battery, and the camera lens as well. So let's add these up and work out our total costs. So we'll just do 45, add 13, add 9, add 3. So 9 and 3 is 12, and 3 takes me to 15, and another 5 takes me to 20. Carry over that 2. 2 and 4 is 6, and 1 is 7. That's 70. So his costs are £70. That means his profit is the difference between the income and the costs. So it's going to be the £91 take away the £70, which gives me an answer of £21 profit. Let's go ahead and plug these into our percentage profit formula. So percentage profit is going to be equal to the profit he makes. Well, we said that that was £21 over the cost. So the cost was £70. And then we need to multiply that by 100. And this is where profit margin is slightly different, because instead of putting £70 of costs on the denominator, we would be putting the £91, which is the sale price of the phone. So that's where those are different. But we want to go ahead and simplify this fraction where we can. 21 and 70 are both divisible by 7. 21 divided by 7 is 3. 70 divided by 7 is 10. So that gives me 3/10. As a decimal, that's 0.3. Multiply that by 100. And that gives me this answer of 30% profit. In other words, the £21 of profit is 30% of the cost. Pause the video and give this question a go. A farmer spends £80 on fertilizer for his apple orchard. He harvests 40 kilograms of apples. He then sells 10 kilograms of the apples to a local farm shop for £4 per kilogram. The remaining apples get bruised in storage, so he is forced to sell them to a cider factory for a total of £24. Calculate his percentage loss. So percentage loss is equal to the loss relative to the cost multiplied by 100. And we need to work out what the cost was. So let's go to our question and have a look. Farmer spends, so that's the cost, £80 on fertilizer. For his apple orchard, he harvests 40 kilograms of apples. He sells, so this is not going to be cost. This is going to be some of our income. So we'll say the income is going to be the 10 kilograms of apples that he sells to a local farm shop for £4 per kilogram. So he gets £4 for every kilogram, and he has 10 kilograms. So that's going to be £40 of income, not profit, but income. The remaining apples get bruised in storage, so he's forced to sell them to a cider factory for a total of £24. So this is also income, the £24 here. So his total income is the 40 and the 24, which takes us to 64. So if you notice, the cost that he incurred, the £80, is actually greater than the income he got, which is why he's making a loss. We can say that the loss is the difference between these two numbers. It's going to be the £80 take away the £64, which gives us £16. So he lost £16 effectively. Let's go back to our formula and pop that in. The loss is £16. Remember, it's relative to the cost. In this case, £80 for the fertilizer multiplied by 100. I can divide both of these by 8. 16 divided by 8 is 2, and 80 divided by 8 is 10. So 2/10 is 0.2. And then we can multiply that by 100 to turn it into a percentage, which is 20%. So it's a 20% loss. If you're using our lesson booklets, you can now complete exercises 1 and 2.